going to be talking about solving rational equations. A rational equation contains at least one rational expression. So rational expression is what we've already worked on. So to solve a rational equation, we're first going to want to factor all of our denominators. We're then going to want to find the least common multiple, or LCM, of the denominators. Once we do that, we're just going to multiply both sides of the equation by our LCD. So remember, LCD is the same thing as an LCM. We're just using it in the denominator, so least common denominator. Then we're going to want to solve for the indicated variable. That might mean if you have a quadratic, you're going to have to solve a quadratic by factoring, or any of the other methods we know. We want to make sure we're watching for solutions that will cause our denominator to be 0. So those are those restrictions that we had when we were doing rational expressions. Now those are our can't be our solutions, because it will make our denominator equal 0. So we're going to go ahead and look at example 1 just as to solve. So a has x minus 1 over x plus 2 is equal to x squared plus 2x minus 3 all over x plus 2. So first thing we need to do is factor denominators. Already factored for us, nothing we can do there. So now we have to look at our LCD. LCD is just going to be x plus 2, since both of our denominators are the same. So we are just going to multiply both sides of our equation by x plus 2. So we're multiplying the right-hand side by x plus 2 and the left-hand side by x plus 2. When I multiply x plus 2 times x minus 1 over x plus 2, our x plus 2's simplify out, and we're just left with x minus 1 on the left is equal to, well, same thing happens on the right-hand side. Our x minus 2's are gone, so we're just left with x squared plus 2x minus 3. So because I see a quadratic term, we're going to want to go ahead and get everything onto one side of the equation set equal to 0, so then we can factor. So I'm just going to go ahead and subtract x and add 1 to both sides. So I'm now left with x squared plus x minus 2 is equal to 0. I know that is factorable, so I can factor it into x plus 2 times x minus 2 equals 0. Sorry, x minus 1 equals 0. So x equals negative 2 or x equals 1. Now this is where you need to check, will either of these solutions make my denominator equal to 0? And x is equal to negative 2 will make that denominator equal to 0, so that is not one of our solutions. So our only solution for this rational equation is x equals 1. So you don't have to go through and state the restrictions, but you do need to know if one of your answers would be a restriction. And if it is, then it is not one of our solutions. Okay, let's look at B. So here again, we don't have any denominators that need factoring. So I see x over x plus 1 plus 3 over x plus 4 is equal to x plus 3 over x plus 4. So my LCD here, orange, LCD is going to be our x plus 1 times our x plus 4. So we're going to multiply left and right side both by x plus 1 times x plus 4, and I'm going to write it as I'm multiplying each piece of this. So I need x plus 1 times x plus 4 multiplied by our first fraction. I need x plus 1 times x plus 4 multiplied by our second fraction, and remembering to distribute it there. And then we need x plus 1 times x plus 4 to be multiplied on the right-hand side. So from here, I see that our x plus 1's will cancel. So I'm just left with x times x plus 4. On our second one, our x plus 4's will cancel. Again, this is what we want, right? We are trying to clear our fractions, so that way we don't have to deal with fractions anymore. So plus 3 times x plus 1. And again, our x plus 4's on this side cancel. So I'm left with x plus 3 times x plus 1. So from here, I'm just going to do some multiplying. So I have x squared plus 4x plus 3x plus 3 is equal to x squared. This will give me plus 4x plus 3. So I'm going to go ahead and move everything to the left-hand side. I want to get it set equal to 0. Minus x squared minus 4x minus 3. So as we can see, most of our terms are now gone, and I'm just left with 3x is equal to 0, which just leaves me with x equals 0. Now we need to just check to see if that is one of our numbers that would turn our denominator into 0. It is not, so our answer is just going to be x equals 0. Looking at C, we have x over x minus 3 plus x over x plus 3 is equal to 2 over x squared minus 9. So I do see that x squared minus 9 can be factored. So I'm just going to factor it as x plus 3 times x minus 3. So our LCD is just going to be x plus 3 times x minus 3. So I'm going to go through and multiply everything by x plus 3 times x minus 3. Again, this is the big difference between solving and just combining rational expressions. So when we were adding and subtracting, you have to multiply by the same thing, numerator and denominator. When we're doing this, we can use that golden rule of algebra. What you do to one side, you must do to the other. So that way we're just able to clear out our fractions. So it makes it a little bit easier than when we're just combining. So now that I have all that notation done, so notation is super important in this, so make sure we're working on that notation. So I see my x minus 3's can be gone from here. So I'm just left with x times x plus 3 plus, here our x plus 3's can be gone. So I'm left with x times x minus 3 is equal to here, our newly factored x plus 3 times x minus 3 is gone. We're just equal to 2. So from here, I'm just going to do some distributing. So I have x squared plus 3x plus x squared minus 3x is equal to 2. I see these 3x's are going to cancel out, so I'm just left with 2x squared equals 2. So from here, you can either subtract 2 and set it equal to 0 and factor, or I see that we just have an x squared, so I'm going to divide both sides by 2. We get x squared is equal to 1. Now I can just go ahead and take the square root of both sides. So I end up with x equals, don't forget when you're solving and you're taking a square root, you have to say plus or minus 1. So now we have to check, are any of these going to cause our denominators to equal 0? The answer is no. So we have two solutions here, so x equals 1 or x equals -1, and you can just leave it right in that format. On to D. So we have x minus 1 over x squared plus 3x plus 2. So we're going to go ahead and factor that into x plus 2 times x plus 1. The other two denominators cannot be factored. So our LCD is just going to be x plus 2 times x plus 1. So I'm going to go ahead and multiply all of our fractions by our x plus 2 times x plus 1. X plus 2 times x plus 1. X plus 2 times x plus 1. Again, notation is very important. So on this first one, both my x plus 2's and x plus 1's are gone. I'm just left with x minus 1 plus. Second one, our x plus 2's are gone. So we're just left with 2x times x plus 1 is equal to, my x plus 1's are gone here. So I'm left with x minus 1 times x plus 2. So we're going to go ahead and do some simplifying here. So we have 2x squared plus 2x equals x squared. This would give me plus 2x minus x, so just plus x minus 2. I'm going to simplify that left-hand side a little bit. So I have 2x squared plus 3x minus 1 equals our x squared plus x minus 2. I'm going to go ahead and subtract over my x squareds, my x, and add my 2. So that leaves me with x squared plus 2x plus 1 is equal to 0. This x squared plus 2x plus 1 equals 0 is factorable. This is going to factor into x plus 1 squared equals 0. So from here, I'll just solve, take their square root. So we get x plus 1 equals 0. So x equals negative 1. Now again, this is where we need to check, will x equals negative 1 give us 0 in our denominator? So we go back up to our original, and I do see x plus 1 in our denominator, which means negative 1 is a restriction on our variable. So our answer here is going to end up being no solution. Okay, looking at example number 2, we want to solve for the indicated variable. So in this first one, we want to solve for e. We're going to start by clearing our fractions the same way that we just did. So we're going to go ahead and multiply, or first we need to find our LCD. So our LCD here is going to be EMC. So we're just going to multiply everything, both sides, by EMC. So first one, we're going to cross out our e's. Those are gone. So MC times C, we're left with MC squared. Here on our second one, our MC's are gone, so we're left with minus E. And then 0 times anything is just 0. We are trying to solve for E, so all we have to do is add E to the other side. So we're really just left with E equals MC squared. So we're following the same exact rules that we were just doing prior, now just using it to solve something a little bit differently. So let's look at B. So we have 1 over C minus C over A squared plus B squared is equal to 0. So again, we got to go ahead and find our LCD. So here our LCD is going to be C times A squared plus B squared. So we're going to go ahead and multiply everything, both sides, by C times A squared plus B squared. C times A squared plus B squared. C times A squared plus B squared. So my C's are able to be gone. A squared plus B squared times 1 just gives me A squared plus B squared. Here, this whole A squared plus B squared cancels out, so I'm left with minus C times C, so that gives us C squared. And then again, 0 times anything is just 0. We're asked to solve for C, so we're going to go ahead and get C squared by itself on its own side. So let's go ahead and add C squared to both sides. So we're left with C squared equals A squared plus B squared. So now in order to undo that squared, we're just going to go ahead and take the square root of both sides. So we have C equals, need that plus or minus, square root of A squared plus B squared. We cannot take the square roots of A squared or B squared because they are connected by that addition sign. So this is just our final answer. All right, C. We have Q over M is equal to 2V over B squared R squared. So we are asked to solve for B here. So again, first thing we want to do is get rid of these fractions. So our LCD is going to be B squared R squared M we're saying b squared r squared m times the left, b squared r squared m times the right. So our m's cancel. I'm left with b squared r squared q is equal to, over here everything except our m's cancel, so 2vm. Now we're asked to solve for b, so we want to get b squared by itself first, so we're going to divide both sides by r squared q. So we're going to be left with b squared is equal to 2vm over r squared q. Now again, to undo that squared, we're going to have to go ahead and take the square root. So I'm going to square root both sides. Square rooting of fractions means taking the square root of the numerator and denominator. So I'm left with b is equal to, we need that plus or minus, square root of 2vm in the numerator. In that denominator, this r squared comes out of our radical to just give us r radical q. And if we remember from when we were working on radicals, we cannot have a radical in our denominator. We need to rationalize it. In order to do so, we're just going to multiply our numerator and denominator by radical q. So my final answer is b is equal to plus or minus the square root of 2vmq all over rq. And that's rational equations.